Hello everyone, thank you for having me today. I would like to talk to you about photovoltaic inverter. So as you know, PV system mainly consists of PV panels, mount, batteries, and inverter. Inverter is an important part of the PV module or the PV system, which can be used for a lot of function in the PV system. So what is the different type of PV inverters? How can we consider the different parameter to choose the PV inverter? What are the different kind of PV inverter? So today I will provide you with a lot of information about this important component. In this first tutorial, we will talk about the first point, the types of PV inverters, and in next video, we'll provide you with the key function, benefits, and consideration for choosing a PV inverter. So let's go. A photovoltaic inverter, as you know, of course, is a kind of electrical equipment. The main task of this inverter is to convert direct current to alternating current. We have here the PV module connected in series and in parallel. The produced energy by the PV panels are DC. So we cannot use this produced energy, for example, in the electrical grid, for example, in some components in the house. So to make the produced energy adaptable for the PV equipment, so we have to use a component called solar inverter. So solar inverter converts direct current to alternating current. So today we'll provide you with a summary of the different kind or the different type of PV inverter, depending on the scale of the PV system, or of course, with the different advantage and the different consideration to take into consideration to make your PV system more performant. So there are many kinds of inverter. We will talk about string inverter, micro inverters, central inverters, hybrid inverters, and the so-called power optimizer. Power optimizer. The first one is the so-called central inverter. As you see in this picture, we have a lot of module connected in series and in parallel. So this is a 3 module connected in series. This is called a string. This is the first string. This is the second string, and this is the third string. When we talk about large scale PV system, we will talk about, for example, 20 or 30 module connected in series. This is just a picture to provide you with a summary of this situation. So, as I said, we have 3 strings connected in parallel. In this PV system, we have just one inverter. This inverter in this situation called central inverter. So the central inverter is designed for large-scale solar installation. We will talk about, for example, 1 megawatt PV system, 1 gigawatt PV system, or more, or for example, some kilowatt installed PV system. Of course, when we talk about central inverter, we have a lot of pros, a lot of cons. The first one This topology of central inverter is suitable for utility scale project and for industrial application. For example, if you want to use just one inverter to minimize the maintenance of your system, you can use just one. About the cons of this situation or this topology, when we talk about central inverter, we have less flexibility and efficiency losses if any part of the array is shaded. When we talk about shading, for example, shading with building or shading with dust, etc. When some module is shaded, so in this situation, we will have loss in the performance of the PV system. This is the first topology. The second one is the so-called string inverter. So this is a string. A string is a serial connected module. In the string inverter, we have one string or one inverter for each string. For the description, is as a connected to connect a series of solar panels to a single inverter. This is a single inverter, and we have a series of connected module called string. About the pros of this situation, it's cost effective. Cost effective if compared with the central inverter, of course, and straightforward installation. About the cons of this topology, efficiency drop if one panel in the string is shaded or malfunctioning. It's the same about if compared with this string with the central inverter. If we have a shaded module in this situation, we will have a loss in performance in the overall system. But if compared with the central inverter, we will have few losses in the same situation of shading. We have the so-called power optimizer, which can be connected in conjunction with the string inverter. So to prevent the problem of shading. So this is the power optimizer, and this is the string inverter. The power optimizer is installed for each module. Okay. The objective of the power optimizer is to enhance and to improve the performance of individual panel against trading. About the pros of this equipment this equipment can improve the performance of the PV system, similar to microinverter. We will talk about microinverter, and the 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 problem of this or the issue of this topology is the cost. If we will have or we will add a power optimizer for each module, we will have additional component to install and maintain and additional costs to have in your PV system. We have also this called microinverter. As the name indicates, we have microinverter means one inverter for each module, one inverter for each module. In this two topology, we have the microinverter and we have the string inverter. The string inverter can convert DC to AC for a string of PV panels, and the microinverter is an inverter for each module, which can convert the power DC produced by the PV module to AC, then will inject in the building. So about this topology, of course, can maximize the power output for each panel. And the first or the most important issue about this situation is the mitigation of shading issue. Okay, the mitigation of shading, because each module is connected with one panels. Of course, we will have higher initial costs and more complex installation in the first beginning of the PV installation. The last topology and the important one is the so-called hybrid inverter. Hybrid inverter can work as inverter and as a regulator in the PV system. So, as you like, we have the solar panels connected in a PV generator. We have the hybrid inverter, which converts the current produced by the panel, which of course type of DC current. This current converts to AC, which can be used, for example, to supply different components like laptop, lighting, etc., and also to charge the batteries. This this one, this batteries can be used if we want, for example, to have like an off-grid PV system with a regulator. In the hybrid inverter, we will have both function. The function of converting DC light or DC current to AC current and managing the charging of the batteries. Also, with this inverter, as the same of all inverters discussed above, we have the possibility to integrate the produced energy by the panels with the grid, with the electricity grid of your region. So about the description, this is a little description. With the hybrid inverter, we can combine solar and battery inverter for managing both solar panel outputs and battery storage. The most important issue in this configuration is the high cost and the complexity of the system. So, finally, all the different discussed inverter can be used for different application depending on the power installed capacity of your system, on the cost, on the condition of shading. So if you have any question about this issue, you can ask me in comment or email me by my email. Thank you for having me today.